Hey, what's up, everyone? So now we're gonna analyze the COVID dataset over here. So we can see the dataset. This particular dataset we're gonna analyze. Okay. So without wasting any more time, so let's start it. Okay. So first of all, we got a Jupyter notebook open over here. Okay. Let's rename it to COVID analysis. Okay. That's good. So first thing first. First of all, we're gonna import all the necessary libraries. Okay, which we're gonna need to analyze this particular data set. So okay, so let's starting with the pandas library. Pandas as then we're gonna import NumPy library as NP. So pandas library is going to be used for data manipulation. Okay, in Python it's a very powerful data manipulation library in Python. And in NumPy library it's going to be used for numerical computing, and it is often used in conjunction with pandas. So using import, now we're going to import matplotlib dot pyplot as plt. Okay, so this particular library is also very one of the very popular libraries in Python. So it basically for the most part provides a MATLAB like interface for creating plots. Okay, and lastly we're going to import Seaborn, which is a very important library over here, as SNS. Okay, so next okay, so moving on, next we're going to add this particular function, data is equal to dot read. So we have to make Jupyter notebook read our data set. Okay, and so yeah, the data set name is country underscore wise dot latest. So we have to be very specific about the data set name. Even a small pinch of error in naming our data set is gonna cost us errors. Okay, so let me cross check again. Country underscore wise underscore latest. Yeah, gonna read it. So this particular data set contains the COVID analysis data. So read underscore CSV over here. It's basically for the most part a function from pandas, which is already imported as PD over here in the first column. And so CSV file gonna be like country underscore wise underscore latest dot CSV. It's gonna read the CSV file into a pandas data frame. Okay, and the data frame is assigned to the variable data over here. So after running the code, the data frame will contain the contents of the CSV file, allowing which gonna allow us to analyze and manipulate the data using pandas. So now we're gonna data.head. So now it's gonna read us the data. Let's wait it. Yeah, so this head function data.head, it's gonna help us in displaying the first 5 rows over here. Okay, so if I'm gonna add 10, it's gonna display the first 9 rows. See, okay, if similarly if I'm gonna add 20 over here, it's gonna read the first 19 rows and so on. So we need only first 4 or 5 rows over here. So I'm gonna keep it empty. Yeah, so by default it displays the first 5 rows, but you can pass a number inside the parentheses to specify a different number of rows. As I've already showed you, you can add data.head bracket 10 would display the first 10 rows. This method is for the most part useful for quickly inspecting the contents of the data frame and getting a sense of what the data actually looks like initially. Okay, and it can also help you to verify that the data was read correctly and understand for the most part the structure of the data frame. Okay, so moving forward, so now we're gonna add a different code over here, data.columns. So we need columns over here, and this particular attribute is used to retrieve the column labels of a data frame called data. Okay, and so it returns a panda index object containing a column label. Okay, so let's close the brackets. So we're gonna have an output over here. Just a second, I think we have a error over here, so let's cross check it again. Yeah, okay, so yeah, so we have an output over here, And so when you call data.columns, you will get a list like object as we have over here in index format containing the names of all the columns in your data frame. So this can be used for various operations such as accessing the specific columns, iterating over columns, or performing data cleaning and manipulation tasks. Okay, and so this will give you the output of name of all the columns in our data set. So it is giving us output names of all the columns in our data set. As you can see, new cases, new deaths, new recovered, death per 100 cases, recovered, active, as you can see over here, confirmed, death, recovered, active, new cases, new deaths, new recovered cases, death per 100 cases, recovered per 100 cases, and then recovered last week, as you can see over here. Okay, so it is gonna give us all the names of the columns which are present in our data set. Okay, so next we have gonna put data.tail. So this method is let me tell you first, is used to display the last few rows. Okay, and data.head, as you can see over here, it helps us in showcasing the first few rows. But data.tail, as the name signifies, head and tail is for last few rows, head is for first few rows. So let me run it, data.tail. Yeah, okay, so now we have the data. We have data for different countries over here: Afghanistan, Albania. Okay, confirmed cases, deaths. Okay, recovered per 100 cases, new recovered, new deaths, deaths per 100 cases, deaths per 100 recovered. Okay, and confirmed, which deaths which were confirmed like last week, 1 week change, 1 week percentage change. Okay, and also the region over here. So for example, data.tail. Similarly, if I, as I told you earlier, data.head, if we add a value over here, just suppose I add 10. So I'm gonna get the last 10 over here. See, okay. See, if I'm gonna add 5, I'm gonna get the 5, last 5. Okay. So let us put it at 10. Okay. And so this method is useful for quickly inspecting the end of the data set and checking for any pattern or trends in the data that may not be apparent from just looking at the beginning of the data set. Okay, so we need such code also to understand the last few rows. Just quickly we can get on to last few rows with this particular code, data.tail. And then moving on, we're gonna use data.describe. So data.describe for the most part is used to generate descriptive statistics. Okay, so it's gonna show us the statistics of this particular data set in description, in detail, and it for the most part calculates various summary statistics for each numerical column in the data set, such as count, mean, standard deviation, and minimum, maximum, and of course the quartile values as well. Okay, so this output will contain the descriptive statistics for each numerical column in your data set. Okay, and so these particular statistics can provide insights into the distribution and also can gives us the central tendency of our data. Okay, so let me see, I can analyze the first 10. So we're gonna get an error over here. We're gonna do the similar thing which we did with data.head and data.tail. So let's just run it without any number. Okay. Okay. So yeah. So moving on. So now I'm gonna add another code over here. Just wait. So let's just run it. I'll tell you what it does. Okay. So data dot is null dot sum expression is basically for the most part used for counting the number of missing values. Okay, every data set has missing values, right? So data this dot is null, data dot is null, is null. This particular code returns a data set, data frame of the same shape as data, where each element is true if the corresponding element in data is nan or false otherwise. Okay, and the further code dot sum, This further reduces the data set to a series by applying the sum method. For each column, it sums the number of true values, which corresponds to the missing values as well in this data set of COVID cases. Okay, and so this will put a series containing the count of missing values in each column of our data set. Okay? And then we have to get the columns. So I'm gonna add data dot columns again, as I did earlier also. Okay, as I did earlier also over here. So I'm gonna re-add it over here. And so as I told you that this particular code data.columns attributes returns a panda index object containing the column labels. Okay, as I've already discussed it earlier. This index object behaves like an array of column names and can be used to access, iterate over, or manipulate the columns of data frame. So this output over here, which we have in index format, this will be the output, the names of all the columns in our data set, as I've already discussed it. So we're going to re-add it over here. Okay, and then finally we are going to be doing our visualization, the first visualization of this particular data set. So I'm going to add a rel plot over here. I'm going to plot it, and x, we're going to assign the value. So over here I'm going to add, let's start with recovered per 100 cases, and the y value, I think I'm going to go with either that, yeah, so that's per 100 recovered per 100 cases, and that's within those recovered 100 cases. Okay, per 100 cases, that's per 100 cases. So moving on, so let's add it. Data. Yeah, so let's see if it works. Got an error over here, just a second. Yeah, so what I did, I misspelled it, so now it's gonna work. You have to wait. Yeah, so chart is being generated over here. So if I want this particular chart in line format, I can see. Okay, well, I just did that to show you guys, so I'll remove it. So this is our first visualization. Okay, so moving on, I'm gonna visualize a new column now. I'm gonna visualize now recovered per 100 cases, and that's per 100 cases. Earlier we visualized recovered per 100 cases, and that's per 100 recovered. So now I'm going to visualize recovered per 100 cases, and y is going to be that's per 100 cases. Okay, so yeah, make sure you don't misspell the rel plot like I did. And recovered. You also have to be specific about the columns, spelling mistakes. Don't do that. These are some basic errors which students do. So I'm going to analyze that's per 100 cases, this column. Okay, and see. Yeah, so it's visualized over here, as you can see. Okay, and then again moving on, I think I'm going to visualize a couple of more cases within rel plot. So let's start it. SNS dot. So I'm gonna visualize a column, new column over here. I think let's do with new cases. Let's analyze new cases. Uh, New cases and new deaths. Let's do that. New cases and new deaths. So I'm going to visualize it in line. Let's see what's going to be the output. We got, just wait. Yeah, equal to over here. Gonna be resulting in a, yeah. So finally we got our chart. Okay, and these are some basic visualization which we have to do in data science. These are very basic things, I'm teaching you over here. Let's reload it without the line thing. Yeah, so we have chart here. Okay, so yeah, so this plot can help you visualize the trend of new cases and new deaths over the time, providing you the insights into the progression of the COVID-19 epidemic. Okay, and so the code snippet which I provided you over here is using Seaborn's library over here, and this is rel plot. Okay, and the function to create a line plot comparing the new cases column against the new deaths column from the data set, of sorry, from the data from data, the kind line thing which I used over here earlier. This argument specifies that the plot should be a line plot. Okay, so if I'm going to add a line plot over here, so I'm just going to add this thing kind equal to line. This is going to give you a line plot. Yeah, see. Okay, so moving forward, so now we're gonna add a pair plot. Okay, so pair plot is quite a heavy plot, I'll tell you, it's gonna take some time to load. So this plot basically this particular function basically creates a grid of axes such that each variable in the data frame which I use over here, which is data, is plotted against each other variable. So for example, for the numerical variable, it creates a scatter plot, and for the categorical variables, it creates a histogram. Okay, and this plot can be useful for exploring relationships between multiple variables in our data set over here. Okay, and also it helps us in identifying patterns or trends. So let's start it. So it's going to be sns dot pair plot, and we got data frame data. So it's gonna take some time, okay, because these are some very heavy visualizations, and there are large number of visualizations that are gonna take place. So it's gonna take a few seconds. So let's wait a few seconds for it to load. It's gonna take a few seconds more, I guess. And in the meantime it gets loaded. Let me tell you that it can also be computationally intensive for large data sets with many variables, so in cases where we have large number of data sets, and those data sets having large number of variables, so computationally intensive thing, it can be carried out using pair plot. As you can already see that it has taken a few seconds. Earlier all our visualizations happened quite quickly, but this one is taking a bit time. So yeah, don't consider that there's some kind of error in Jupyter Notebook. It's working pretty fine. It is just that pair plot takes, a bit extra time compared to other plotting in, Seaborn library. Taking some time. Okay, so finally our pair plot is being loaded over here. Okay, and it's gonna take a few seconds more, I guess. So okay, let's wait. Okay, so finally our pair plot has been visualized over here after a few seconds. So as you can see over here, so as I already told you that so sns.pairplot data function creates a grid of axes. I already told you that, such that the each variable in the data frame data is plotted against each other variable. So these are plotting against each other variables, and also for the numerical variables it creates a scatter plot, and for the categorical variables it creates a histogram. as you can see. Okay, so there are a lot of data visualization which has happened. It's a very heavy visualization which happens with pair plots. Okay, and this plot can be useful for exploring relationships between multiple variables, as I already told you that in your data set, and also it can help you in identify patterns and trends. Okay, and as you already know that I've already told you that it's computationally also it's very intensive for large data sets, and because of large number of variables. Okay, so now moving on to our another visualization, we're gonna do cat plot now. Okay, so sns dot cat plot. Now I'm gonna do cat plot of variable confirmed deaths, confirmed cases, sorry, and deaths in our COVID data set. And also over here, I'm gonna add another thing. I'm gonna have a who HUE, as you can see over here, uh, code over here as well. Okay, here I'm gonna add a third touch over here, which gonna visualize the recovered cases as well. How many confirmed cases are there? How many deaths are there? And also how many recovered cases are there? It's gonna visualize all the three things. Okay. I'm gonna So now let's run this. We got an error, just a second. Yeah, so I made a mistake over here. Let's rerun it. Now it's gonna visualize. It's gonna take a few seconds. Yeah. So SNS.catplot function in Seaborn library in Python is for the most part used to create categorical plots. Okay. So, but however, the use of confirmed cases in this particular data set, deaths and recovered columns suggests that these are numerical values and not categorical values. Okay. So, if these columns contain continuous numerical data and scatter plot, such as SNS.scatterplot or a line plot, such as sns.lineplot, might be more suitable for visualization uh, to find the relationship between these three things. Okay, and so these only like for the most part going to be the numbers over here in recovered, active, new deaths. Okay, as I have already told you that these are numerical values and not categorical values. Okay, and so if you still want to use cat plot for some categorical representation, you can convert these columns into categorical variables by binding them, okay, into discrete intervals. For example, let's say if you can create bins for the confirmed and deaths columns and use them as categorical variables, you can do that. So yeah, okay, and so in this example, confirmed and deaths are bind into 5 categories each, and a bar plot is created to show the relationship between confirmed, deaths, and recovered. I'll show you that how to do that later on. Okay, if you there's need for that. So, however, as this approach may not be ideal depending on the nature of your data and the insights you're trying to gain. So numerical data you can use that. Okay, and but not for categorical. Okay, and so let's do another visualization. Let's do a rel plot again. Okay, with the new cases this time. New cases and another variable. Let me check the whether the D is capital or not, because I have to cross check. You have to cross check these small things as well. Otherwise, your data won't be loaded. D is small as you can see. The small things which you have to care of as a beginner. Okay, and yeah, I'm gonna use a line element over here. I want data to be visualized in line form. So let's run it. It's loading. So yeah, okay. So this code uses Seaborn's rel plot, which we have used earlier also, and so it helps in creating a line plot comparing the new cases, new deaths, new cases against the new deaths. Okay, and so this plot can be helpful in visualizing the relationship between new cases and new deaths over the time, providing insights into the progression of an epidemic, COVID-19. Okay. So if I remove the line element over here, I'm gonna get it in different format. Visualize it in non-line form. Yeah. Okay. But if I want it in, so this is a very basic project which you need to do. When you are just taking stepping stones into your data science journey. Okay. So let's now do another rel plot, or okay, let's do a strip plot this time. Okay. Do a strip plot. So SNS dot is another kind of visualization. SNS dot strip plot or another column. Let's do it. Let's do a country region. That's confirmed deaths, not confirmed cases. That's how many people died COVID-19. Tell you what is exact reason why we used it. Let me visualize it first.